Hello everyone, welcome to this Smart Crop Monitoring System project. In this project, we use an ESP32 microcontroller to monitor environmental conditions that affect crop growth. The system measures temperature, humidity, and light intensity, and displays the data on an OLED screen in real time. The components used in this project are an ESP32 development board, DHT11 temperature and humidity sensor, LDR light sensor module, 128 by 64 OLED display, breadboard, and jumper wires.
Before we begin the project, let's first make sure that our ESP32 board is working properly. Here, an LED is connected to GPIO32, also known as D32, through a 220 ohm resistor. The LED blink program has already been uploaded to the ESP32, so no additional programming is required at this stage. To perform the test, we simply power on the ESP32 board. Once power is supplied, the microcontroller starts executing the uploaded code automatically. As you can see, the LED connected to D32 is blinking continuously. The LED turns on for a short duration and then turns off repeatedly according to the programmed instructions. This simple test is commonly used to verify that the ESP32 is receiving power correctly, the microcontroller is functioning properly, and the previously uploaded code is running without any issues. Since the LED is blinking as expected, we can confirm that the ESP32 board is working successfully and is ready for the next stage of the project.
Now, let's begin with the power connections. Place the ESP32 development board on the breadboard. First, connect the 3.3 volt pin of the ESP32 to the positive power rail of the breadboard. This rail will be used to distribute power to the sensors and display module. Next, connect the GND pin of the ESP32 to the negative rail of the breadboard. This creates a common ground connection for all the components in the circuit. Next, let's connect the DHT11 temperature and humidity sensor. The DHT11 sensor is used to measure the surrounding temperature and humidity of the crop environment. First, connect the data pin of the DHT11 sensor to GPIO4 of the ESP32. This pin is responsible for transmitting sensor data to the microcontroller. Next, connect the GND pin of the DHT11 sensor to the negative rail of the breadboard to establish a common ground connection. Finally, connect the VCC pin of the DHT11 sensor to the positive power rail of the breadboard to provide power to the sensor. After completing these connections, the DHT11 sensor is ready to monitor environmental conditions and send real-time temperature and humidity readings. Now, let's connect the LDR light sensor module. The LDR, or light dependent resistor, is used to measure the intensity of light falling on the crops. First, connect the DO pin of the LDR module to GPIO34 of the ESP32. This pin allows the ESP32 to receive the light detection signal from the sensor. Next, connect the GND pin of the LDR module to the negative power rail of the breadboard. Then, connect the VCC pin of the LDR module to the positive power rail of the breadboard. Next, let's connect the 128 by 64 OLED display. The OLED display is used to show real-time sensor readings such as temperature, humidity, and light intensity directly on the device. First, connect the SDA pin of the OLED display to GPIO21 of the ESP32. This pin is used for data communication between the display and the microcontroller. Next, connect the SCL pin of the OLED display to GPIO22 of the ESP32. This pin provides the clock signal required for I2C communication. Now, connect the GND pin of the OLED display to the negative power rail of the breadboard. This establishes a common ground connection with the ESP32. Then, connect the VCC pin of the OLED display to the positive power rail of the breadboard. This supplies power to the display module. Now that all the hardware connections have been completed, let's test the Smart Crop Monitoring System. Power the ESP32 using a USB cable. Once the system starts, the OLED display will initialize and begin showing real-time sensor readings. First, let's test the LDR light sensor. When the amount of light falling on the sensor changes, the light value displayed on the OLED screen updates accordingly. Covering or exposing the sensor to light will produce different readings. Next, let's observe the DHT11 sensor. The sensor continuously measures the surrounding temperature and humidity and sends the data to the ESP32. These values are then displayed on the OLED screen in real time. As the environmental conditions change, the displayed readings update automatically, demonstrating the proper operation of the sensors and the display module. This confirms that our smart crop monitoring system is functioning successfully. Thank you for watching our Smart Crop Monitoring System project. In this project, we used an ESP32, DHT11 sensor, LDR sensor, and OLED display to monitor temperature, humidity, and light intensity in real time. We hope you enjoyed this project and learned something new about smart agriculture and IoT. Thank you once again for your support. See you in the next project. Goodbye.